Imagine a substance so explosive, it's become the benchmark for measuring the power of other blasts. A compound that's been used in wars, construction, and even as a standard unit of energy. Welcome to the incredible story of TNT, the explosive that's shaped history. TNT, or Trinitrotoluene, is a chemical compound first synthesized in 1863 by German chemist Julius Wilbrand. Initially, it was used as a yellow dye, but its explosive properties soon made it a game-changer in the world of warfare and industry. How TNT is made. The production of TNT involves several steps. Picture a high-stakes chemical ballet, where molecules whiz through the air, and the stakes are explosively high. In a specially designed reactor, toluene, a common liquid hydrocarbon derived from petroleum, is carefully mixed with a potent nitrating acid, a blend of sulfuric and nitric acids. This explosive cocktail is stirred and controlled with precision, as the acid's nitric ions, NO3, latch onto the toluene molecule, adding nitro groups, NO2, in a carefully choreographed sequence. The temperature is meticulously managed, as even a slight deviation could spell disaster. This delicate dance adds the magic ingredient, transforming toluene into a powerful, energy-dense compound, the foundation of TNT. The nitration process is the starting point of TNT's incredible journey, where chemistry and precision come together in a thrilling display of molecular engineering. The nitration party's over, and now it's time for cleanup. The resulting mixture is treated to a rigorous purification process, where impurities are washed away like yesterday's news. Think of it like refining a precious metal, where every detail matters, and only the finest quality will do. Hot water, solvents, and clever chemistry combine to remove unwanted byproducts, residual acids, and other contaminants. The TNT is scrubbed, rinsed, and dried, emerging cleaner and purer with each step. It's a meticulous process, requiring patience, expertise, and a keen eye for detail. The goal? To create a product that's not just explosive, but reliable, stable, and safe to handle. After all, you don't want any surprises when working with high explosives. The purified TNT mixture is slowly cooled, and the molecules begin to slow their frantic dance, coming together in a beautiful, intricate pattern. It's like watching a snowflake form in midair, except this snowflake is explosive. As the mixture reaches the perfect temperature, the TNT molecules start to crystallize, forming a distinctive yellowish solid. The crystal lattice structure is taking shape, with molecules aligning in a precise, three-dimensional pattern that will ultimately give TNT its remarkable explosive power. The crystallization process is a delicate balance of temperature, pressure, and chemistry, requiring careful control to produce high-quality crystals that will perform consistently and reliably. As the crystals grow, the mixture transforms into a vibrant yellowish solid, a sign that TNT is taking shape, ready to unleash its fury. Flaking or prilling, the final form. The crystallized TNT is now ready for its final transformation. The yellowish solid is fed into a specialized machine that flakes or prills it into small, uniform particles. It's like watching a chef expertly chop fresh herbs, except instead of parsley, it's powerful TNT. The flakes or prills are designed to be perfectly sized for their intended use, whether it's demolition, mining, or manufacturing. As the particles take shape, they're carefully collected and packaged, ready to be shipped to industries and applications around the world. With this final form, TNT is now primed to unleash its explosive energy, shaping landscapes, building infrastructure, and defending nations. The process is complete. TNT is now a potent, versatile tool, ready to make its mark. TNT's explosive power comes from its nitro groups, which decompose rapidly when detonated, releasing massive amounts of heat, gas, and pressure. This process is called detonation, and it's what makes TNT so effective as an explosive. But how does TNT's explosive power compare to other explosives? Well, TNT is often used as a benchmark, with a power rating of 4.6 megajoules per kilogram, mjkg. Let's compare TNT's explosive power to other heavy hitters. Dynamite packs a bigger punch, with a rating of 7.59.0 mjkg, but it's also more prone to unwanted shocks. RDX, on the other hand, outdoes TNT with a rating of 5.7 to 6.3 mjkg, making it a favorite for specialized applications. Environmental impacts of TNT production. Unfortunately, TNT production has significant environmental impacts. The manufacturing process generates hazardous waste, including toxic chemicals like nitroaromatics, which can contaminate soil and groundwater. Production facilities and surrounding areas can become polluted, posing risks to local ecosystems and human health. In fact, the environmental impacts of TNT production are so significant that many countries regulate its production and disposal. New technologies and processes are being developed to reduce TNT's environmental footprint, focusing on waste minimization and pollution prevention. Despite these challenges, TNT is still used in modern construction and demolition. It's used to bring down buildings and structures in a controlled manner, and in mining and quarrying to break up rock and extract minerals. However, alternatives like ANFO and emulsions are increasingly being used, as they're often safer, more efficient, and have fewer environmental impacts. TNT's legacy is complex, with both significant contributions to industry and devastating impacts on human health and the environment. If you have any questions or comments, please leave them below. Your input matters. Share your ideas for our next video in the comments, and we'll recognize your contribution. Thanks for joining us on this exploration of the fascinating stories behind everyday things. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching. And if you want to learn more, click the next video right here.